Okay, 4.2 is dot product. So dot product, or another name for dot product, is inner product of two vectors, is used to describe the length, distance and angle of vectors. Okay, what is dot product? Okay, let u and v be two vectors in two dimension or in three dimension. So the dot product of vector u and v is defined as, so for two dimension, u dot product v is given by a product of a component for each dimension for the given vector. Okay, for example, if u1, u2 is from vector u and v1, v2 is from vector v, so the dot product of vector u and v is given by, so we look at the same component u1 times v1, so it becomes u1 v1, and add with second component is u2 times v2. So the answer for dot product of u and v in two dimension is u1 v1 plus u2 v2. So this is the formula for dot product. So the answer here will be the value. Okay, will be the value or any numbers. Okay, that's represent magnitude or scalar. Okay, for three dimension also the same. Let's say with three dimension for vector u is given by u1 in I dimension direction, u2 in j direction, u3 in k direction. Okay, multiply or dot product with vector v1, v2, v3 in I, j and k dimension in vector v. So the answer, so we just multiply the component in the same direction. So u1 v1 plus u2 v2 plus u3 v3. So this is the answer. Okay. And the product of the two vectors, the component or the dimension of the two vectors must be of the same dimension. Then only we can proceed with the dot product. Alright. Okay, in algebraic properties of dot product. So this is the properties. So it is interchangeably where u dot v equal v dot u. So we can use any order of u and v. It doesn't matter. Okay, for u dot bracket v plus w, so we can distribute. Okay, distribute as if u dot v plus u dot w. Okay, for scalar c, multiply by vector u dot v, so we can dot product first u and v and then multiply by scalar c. Okay, for dot product of the same vector, it must be positive, it must be greater than 0. Okay, if the two if the given vector u is not 0. Okay, and u dot product u is 0 if and only if vector u is a 0 vector. Okay, next, length. So now we find length of the vector. Let's say vector v from point A to B is a vector in two dimension. So the length of vector v is given by this formula. So this is the symbol of length of a vector. So the formula length of the vector is given by if v is a two-dimension vector, so component in I direction v1, component in j direction is v2. So the length of vector v is given by root of component I v1 square plus component j v2 square. Okay, example. Okay, let's say v is given by vector component 2, 3, or it can be written as 2i plus 3j. Okay, in a vector form. Okay, this is in the scalar form. Okay, so now the length of v is given by, just use the formula 2 square plus 3 square. So answer is 4 plus 9, which is 13. So this is the length of vector v. Okay, same also goes for 3-dimension vector. For example, the v is given by 2, 1, 3, or in a vector form 2i plus j 2i plus j plus 3k. Okay, so by using the formula of length, v is given by 2 square plus 1 square plus 3 square. So answer is 4 plus 1 plus 9, which is 14. Okay, so this is the length of a vector. Okay, next is Cauchy-Schwarz inequality. So Cauchy-Schwarz inequality, this is the theorem or the formula. It's more on the theory introduced by this person. Given that for all vectors u and v in space n, u dot v must always be at least. Okay, must always be not at least. This is at most, because the minimum it can get is length u multiplied by length v. So this is at most. Okay, at most must be dot product of u and v must be at most multiplication of length u and length v. Okay, so this one can be proven. Okay, next is, later we can look at the example of these two. Okay, for distance, earlier is the length. Okay, earlier here is length. We have different formula for length and also formula for distance. This is the distance. This one, distance between vectors, between two vectors. Normally distance between the two vectors. Okay, but length is length of one vector. Okay, distance, the symbol distance of vector, distance between vector u and v is defined as, for two dimension, we take the difference between component in vector u and v. So we have u minus v and take the length formula. Okay, given by this formula. So this is the gap or the difference between, or the distance between the two vectors given. Okay, so this is the gap between the two vectors, or the length between the two vectors. So this is also the length between the two vectors. So u1, this is component I, u1 minus v1, this is component j, u2 minus v2. Okay, example, let's say u given is 2i plus j and v given is 3i plus 2j, example. Okay, so now the distance, by using the formula, the distance is the distance between u and v given by, so u minus v, 2 minus 3, because we have square here, so the answer is always positive. Okay, and then plus 1 minus 2 square. Okay, 1 minus 2 square. So answer is minus 1 square plus minus 1 square. So answer here is 1 plus 1, which is the distance given by is set 2. Okay, and next for angle. Okay, for angles means that the degree between the two vectors given by a formula cos theta. So this is let's say this is u, this is vector u, and this is vector v. Okay, so this is theta. So this angle between two vectors given by formula u dot v over distance of u and distance of v. Okay, for example, let's say we have this u and v given. Okay, let's say we take this example, this is u, this is v. Find theta, the degree between the two vectors here. So cos theta is u dot v 2i plus j dot 3i plus 2j, okay, over so length in u is given by 2 square plus Okay, 2 square plus 1 square. 2 square plus 1 square. And then multiply by 3 square plus 2 square. Okay, so you solve this one. So finally you find theta. The degree will be the inverse cos using a calculator. Inverse cos of the given equation that we obtain here. Okay, so this is 6 plus 2. Okay, over 4 plus 1 is 5, and here is 9 plus 4 is 13. Okay, try to get answer. What's the given answer here? Okay, try to finish it. Alright. Okay, next is cross product. Okay, cross product is to find a vector that is perpendicular to a given two vectors. For example, we have vector u and we have vector v. Okay, u cross product v is the result is the vector that is perpendicular to both vector. Perpendicular to vector u, and it is also perpendicular to vector v. So this is the vector given here is a cross product of vector u and v. Okay, so this is what the cross product means for vectors, for two vectors. Okay. Okay, now let's say we have two vectors in 3 dimensions. The cross product of vector in 3 dimension or 3 space is given by this formula. Okay, so how to get this one? This formula is obtained from the determinant formula of matrix 3 times 3. Okay, we have learned determinant of matrix 3 times 3, where the first row is the direction of I, j and k. Second row is the component of the first vector, and third row is the component of the second vector. So find the determinant of this matrix, so we are able to get the result of the product or the cross product of two vectors. Okay, for example, for direction I, remove column I and row I, so get the determinant of this one. Determinant of 2 times 2 is u2 v3 minus u3 v2, given by this. u2 v3 minus u3 v2. Yeah, this is I component. Okay, for j component, we have remove column and row. So this is negative. It should be negative j. Okay, should be negative here. Remove this, and we get negative u1 v3 minus. So minus negative should be in front here. Okay, this is negative j. Okay, negative j here. Negative j. So negative of u1 v3 minus u3 v1 So we have here, so negative and negative become positive. u3 v1 minus u1 v3. Okay, u3 v1 minus u1 v3. Okay, for k dimension. Okay, for k dimension, remove, we have u1 v3, k dimension, u1 v2 minus u2 v1. So we have, this is I direction, this is j direction, and this is k direction. Okay, in the component form, we only put the magnitude or the scalar only. And we just for vector form, then only we write the direction I, J and K. Okay, but in a component form meaning that we have this form. Okay, this form, so we just write the component form. For the vector form, this is component form. Okay, for vector form, then only we write component I plus component J plus component K. Okay, example here. Find U cross product V where U given by 1, 2 and minus 2 and V is 3, 0, 1. So U cross product V. Okay, so U cross product V, so we write U cross product V as I, J and K. 1, U is 1, 2, minus 2 and V is 3, 0, 1. Okay, find determinant of this. So this is in the component form I, J and K. So we will get this answer. Okay. Okay, example 2. U cross product V is perpendicular to U and to V. So now consider the vectors U and V. So U cross product V. So using the determinant form here, so we get this component. So now let's say we find U dot U, this one dot this component. Okay, when U dot this component, 1 times 2 plus 2 times minus 7 plus minus 2 times minus 6. So solve this one, we get 0. Okay, so when we solve this one, when we solve this, we'll get 0. Okay, for V dot U cross V, V dot this one, 3 times 2 plus 0 times minus 7 plus 1 times minus 6. Solve this, we get 0. So since U dot U cross V and V dot U cross V is 0, both are 0, we say that U cross V is orthogonal to both vector U and V. So this is the property of orthogonality. Okay, since U dot, so these properties is true whereby U dot U cross V is 0, V dot U cross V also this both property must be the same, which is 0. The answer we must get must be 0. Then only we say U cross V is orthogonal to both U and V. Okay, so U dot V is 0. So if U dot V is 0, we say that U is orthogonal to V. Same also for this. U dot U cross V 0, V dot U cross V 0. So U cross V is orthogonal to U and U cross V also orthogonal to V.